Okay, picture this. You're on a beach, you've got a metal detector, and you're just sweeping the sand, right? You're not looking for one specific thing. You're just listening for that beep, that sign that there might be treasure buried underneath. Well, that's a lot like medical screening. It's a search for clues to a problem, long before you'd ever have a reason to think it was there. So today, we're going to unpack how this incredibly powerful idea works and, well, why it's a lot more complicated than it seems.
So here's our game plan. We're going to start with the basics, what screening actually is. Then we'll get into how it's different from a diagnosis, super important distinction. We'll tackle a tricky little paradox about early detection, lay out the official rulebook for what makes a good screening program, and finally, we'll dive into the real nitty-gritty, how we measure if a test is truly accurate.
All right, first up, what exactly are we talking about when we say medical screening? It all boils down to one really profound question.
I mean, think about it. Most of the time, we only go to the doctor when something's already wrong, when we feel a symptom. Screening just flips that whole idea on its head. It's medicine's way of proactively looking for trouble in people who feel perfectly 100% fine. And here's the official definition. It's the search for disease in apparently healthy individuals. Now that's the phrase to remember, apparently healthy. This isn't for people who are already sick. It's a proactive sweep, using quick and easy tests across a huge number of people to find those hidden clues. For a screening program to even work, it has to be a big, efficient operation. It's all about prevention. It needs to be something you can apply to tons of people, it has to be pretty cheap, and it can't take up a lot of a doctor's time. It's really the total opposite of an intense, one-on-one medical investigation. And that brings us to something that trips a lot of people up. Is screening the same thing as getting a diagnosis? The answer is a hard no, and the difference is absolutely crucial. So here it is, the core difference. Screening is done on groups, on whole populations of healthy people. And its results? They're just a signal, a starting point that says, hey, maybe we should look a little closer here. But a diagnosis, that's for one specific person, an individual who already has symptoms. And those results, they're the final word. That's the basis for treatment. Let's look at some classic examples you've probably heard of. A pap smear, a mammogram, a digital rectal exam. All of these are screening tests. They're looking for the earliest signs of cancer in people who, again, feel totally fine. If you get a positive result on one of these, it does not mean you have cancer. It just means it's time to move to the next step, which is a proper diagnostic test. Now, this is where things get really fascinating and honestly a little weird. We all just assume that finding a disease earlier is always better. But is it? This is where we get into something called the lead time paradox. Okay, let's look at this timeline. So a disease starts to develop. Now, without any screening, you'd probably get a diagnosis way over here at point B, when symptoms finally show up. But with screening, we can spot it way earlier, back at point A. And that gap, that chunk of time between A and B, that's what scientists call lead time. And here's the mind-bending part. If a screening test finds a cancer 5 years before symptoms would have appeared, it might look like that person survived for an extra 5 years. But what if the final outcome is exactly the same? Did they actually live longer, or did they just live for 5 more years knowing they had cancer? That statistical illusion is called lead time bias, and it's a massive challenge when we try to figure out if a screening program is truly saving lives. So, with all these tricky parts, how do public health experts even decide what diseases we should screen for? Well, it's not random at all. There is a very strict rule book, a checklist, for both the disease and the test itself. First off, the disease. It has to be a big, important health problem. And this is key. There has to be a treatment that actually works. There's also got to be a long, silent period where we can catch it before symptoms appear. I mean, it's kind of pointless to screen for something if you can't do anything about it once you find it, right? And then there's the test itself. People have to be willing to do it, so it can't be too awful or too expensive. It also has to be reliable. It should give you the same result over and over. And of course, it has to be valid, meaning it actually measures the thing it's supposed to be measuring. Finally, the benefits have to clearly outweigh the costs and the harms. All right, for our last section, let's get into the weeds a little. We've used words like validity and accuracy, but how do we actually measure that? This is where we need to understand two of the most important ideas in all of medical testing: sensitivity and specificity. Okay, first up, sensitivity. Think of sensitivity as a test's detection power.
A test that's highly sensitive is amazing at finding the disease in pretty much everyone who actually has it. It almost never misses a real case. You could call it the true positive rate.
Then, on the other side of the coin, you have specificity. This is the test's ability to correctly give healthy people the all clear. A highly specific test is fantastic at not raising false alarms. It correctly identifies people who are disease-free. This is your true negative rate. So, to really understand how well a test performs, every single result gets sorted into one of 4 boxes using this simple grid. It's based on 2 things. Do you actually have the disease? And what did the test say? Everybody lands in one of these 4 squares. Let's just break that down real quick. True positives and true negatives, those are the good ones. The test nailed it. But the other 2, that's where things get messy. A false positive can cause so much stress and lead to unnecessary, sometimes even risky follow-up tests. But the false negative, well, that might be the most dangerous of all. It tells a sick person they're fine, giving them false reassurance and delaying the treatment they really need. And all of this leads to one final, huge question. In a perfect world, our test would be perfect. It would never miss a case, and it would never create a false alarm. But in the real world, there's almost always a trade-off. If you make a test more sensitive to catch every single case, you almost always create more false positives. So what do? What's more important? A test that never ever misses the disease, or one that never ever scares someone for no reason? Finding that balance, well, that's the constant challenge at the very heart of medical screening.